So we're LightUp, and we're democratizing hands-on learning. Now, as Aya from Little Bits mentioned earlier today, the world of electronics opens up a giant range of amazing projects that kids can do, from creative projects, interactive ones, functional ones. Unfortunately, nowadays, when kids want to use electronics, they often have to decipher things like this. And without expert guidance or a mentor nearby, it can be very hard for them to get started and very easy for them to get lost along the way. Now, as a teacher, I wanted to inspire the kids that I teach to be able to learn and innovate to solve the problems of the future, many of which are technological. And that's why we created LightUp. So LightUp is a powerful combination of hardware and software. On the hardware side, we have electronic building blocks that you can connect together, and you'll see that in a second. And on the software side, we developed an app that allows kids to use augmented reality and computer vision. So, well, not that they need to know that, but they use the app. They can take a picture of what they built, and our app can basically function as an interactive tutor and a debugger. So with that, I'd like to ask, well, I guess Jason already chose, so with the two guys who volunteered, come on, please. Thanks so much. So if we could switch to the Elmo, please. Hi.
Again.
Oh, yeah.
So what's your name?
Sean.
Sean? Sean.
Ishan.
Ishan.
Yeah.
Ishan.
What grade are you in?
Second.
8th or 2nd grade? We're going to split the difference, 4th?
Second.
Do you think you're in 8th sometimes? You're just that much smarter than the 2nd graders? Is this your big brother?
Yeah.
Okay, what's your name, big brother?
I'm honest.
And what grade are you in?
8th grade now.
You sure it's not 2nd?
Yes.
You gonna stick with that answer?
Yes.
Final answer, okay. No, I just want to make them comfortable, which obviously is not working. All right, just wanted to make sure. And who's here? Your mom or your dad?
My mom.
Mom.
Is your mom a teacher?
Yeah.
Awesome.
Is she a good teacher?
Yeah.
What does she teach?
Um.
Did you ever talk to your mom about her job?
She teaches preschool and stuff. So.
Awesome. All right, go ahead.
Okay, well, thank you, Jason. It's very nice to meet you. Ishan and Manas, is that correct? Okay, so I'm Josh, and so we're going to work in this camera to the audience and kind of see what we're doing. But I mentioned that LightUp has electronic building blocks. So what you see here, here's like actually a working circuit, but we have different components mounted on blocks that connect magnetically. So if you like, you guys can both kind of get around the table and try it out. Have you guys built circuits before?
No, I haven't.
Oh, how about you? Oh, wow, so we're going to see,
When you ask them a question.
Oh, good idea. Okay. So we're going to see Ishan and Manas build circuits for the very first time, live streamed on stage here. So, so this is a battery, and that's really important because you need something to power the circuit. These are wire pieces you see, and right here I just gave a button, an LED which lights up, and a motor. So I'm really interested to see what you guys do since you guys haven't done this before. So go ahead, maybe work together. Yeah, and I'll help you out if you have any questions. So one hint I can give, and I think it's good to know this, is that a circuit needs a power source, and I've given you that with the battery. Another important part of a circuit is that it needs to be connected completely in a loop. So you can think of it as a circuit has to be a circle of sorts. So, so that's one piece of advice I give. So it's almost a circle. And also, you might want to not put in everything right away. I would advise you to start simpler and then get something that you like, and then maybe add in things after. But it's up to you. So Manas brings up a good point that there's a battery there. So it's almost a loop, right?
Yeah.
So what can you do to complete it? Oh, you're out of wires. Huh? You guys built a big circuit. So here, I'll give you a couple more wires. So why don't you try completing that? Can you guys see? Yeah. Okay. So now what? So you put a button in there, and do you guys have an idea what a button does?
No.
Well,
Something, I guess.
it's pretty similar to a switch. Like when you go into your room and turn on your light. That's basically what a button is. It's a switch. So if you want, you can try pressing it like you would in your house. So interesting. So you have to keep pressing it for it to stay on. Okay. So I don't know if the audience can see, but the LED did light up. But the motor didn't spin, you might notice. So that's an interesting thing that, it would light up, we would talk about more. Why not take out one? Why not just put one component or the other and then see what changes? So yeah, replace it with a wire piece. Yeah. Let's see. Oh, go ahead. Oh no, it didn't work. Ah, there it is. So you see it's brighter. I don't know if you guys can see on the screen. Now what happens if you change the LED with something else there, like maybe the motor that you were using earlier? Oh, there it goes. Okay. Well, thank you very much. So these were the very first circuits that I guess Ishan and Monis built on stage. So if you guys give them a round of applause. I just want to say, so in addition to, I guess, the iTunes gift cards you guys are getting, I also wanted to give you this card, which will, here it is. When the LightUp kits are ready and for sale, I'll send you guys a pair. So just send me your address.
Thank you.
Sure, maybe a bigger one or something. I'll figure it out. Thank you, you too.
Thank you.
Yeah. So, they did a great job demonstrating kind of like a very basic example. I'm really impressed because this is the very first circuits they built. They didn't touch a breadboard, a soldering iron, alligator clips. But I wanted to talk a bit more about other elements of the LightUp platform, which I'll do on camera as well, but just myself. So, I have a circuit here, and now they were pretty. I don't know if they were lucky or fortunate, or if they knew this and didn't tell me. But when they built it, their first circuit worked right away, like the LED lit up. A common mistake that I found teaching electronics is that kids really want to get something working, so they build a circuit like this, and they put in an LED like this, and they know the battery's working, they know the LED's working, but it's just not lighting up. And on the one hand, as a teacher, I feel that these mistakes are very important learning opportunities. On the other hand, I don't want kids to become so frustrated that they give up, and that's kind of the basis of the app that we created. So I'm going to quickly give a demo. So here's the app running on a tablet right now. So I'm going to take a picture of the circuit right here, you see. So we basically built this platform to have codes in each block that our app can recognize. So if you look carefully, sorry, I'm sorry, it's really hard to see, but.
We can see it.
Oh, sorry, I shouldn't have stopped. Let me. Oh, you guys could see it. Okay, let me do it again then. Sorry.
So to be clear, you're taking a picture of it?
Yeah, so I'm taking a picture right now. Oh, let me get this out of the way. Okay, so yeah, I'll do it again. So I took a picture, and hopefully the contrast is not so intermittent. So, okay, if I move it. Oh, now you can see it. Okay, there you go. So, so here's a bug in the prototype app I made. But what it says is that it detected that the LED was put in backwards, which is a fundamental property of this particular component, a diode. And it did label it twice, but there's an arrow going around it, and it says, uh-oh, the LED is backwards. So it's just in time kind of help debugging, if any of you engineers, software engineers might recognize this. But in a context of hands-on learning and hardware, and it's made possible in a more scalable manner because we're using tablets and smartphones, which are becoming more ubiquitous and cheaper as we move on. Now, so given this suggestion or given this hint, a kid might think about that and change it around and get the circuit to light up like this. And for the sake of time, I just took the picture earlier today, but here's what would appear when they take the picture of that circuit. So we're able to use augmented reality, overlay it over the circuit, over hardware, to explain phenomena, concepts that are normally invisible, like current flow, voltage, and so on. So, last thing. We also want to have a higher ceiling is kind of the term in pedagogical circles. And so we're developing a part of LightUp to really get kids, once they've learned the basics of electronics, to learn another really important field these days, programming. And some of you, show of hands, how many of you have heard Arduino before, or heard of Arduino? Oh, that's quite a few. So we're working actually, we've made an Arduino compatible block, which I can show you right here, and we've pre-programmed. So this, as you can see, is a little bit more complicated than what the two guys built earlier, but it's using the same exact blocks, and they're all compatible. So I'll just steal the battery from this circuit and connect it here. And this was already pre-programmed by me. But I pre-programmed it with an input. This is a light sensor. So if any of you guys have like a night light at home, that would be the sensor that kind of detects when it's dark or bright. And an LED that's attached here. And what I can actually do here, if you look, I can change the frequency of the light that the light is blinking in by how much light is hitting that light sensor. So as it gets darker and darker, it starts blinking faster. So this is a simple example, but really the possibilities of what kids can do with projects really expands, multiple, I don't know, tenfold at least when you have programming in the mix. Because now you can not just build things that light up, spin around, but you can build functional projects, creative projects, things like that that are made possible with a platform like Arduino. And another great use of Arduino is that there are already a lot of services being developed on top of it, like graphical programming. So I've seen kids as young as 5 and 6 program because they're not really typing in code. They're able to drag and drop these blocks in. I think someone mentioned Scratch earlier. So Scratch, ModKit, there are these companies that are already working on this problem, and they work seamlessly with our platform because it's Arduino based. So just to give a recap, oh sorry, can I switch back to the slides? Thanks. So with LightUp on the hardware side, we have magnetic blocks. It's Arduino compatible, which is a free and open source platform that's on Windows, Mac, and Linux. And we have modular blocks that are really component specific, so kids can really feel free to explore all sorts of different projects. And on the software side, we have debugging capabilities, as you saw on stage. We have the ability to plug in the circuit into an interactive simulator. So eventually we'll have this plugged into a actually industry standard ngSpice simulator, so any circuit built will be able to be kind of, we'll be able to figure out what's going on. And ultimately, we'd like to bring in guided lessons into the mix, so really help kids expand beyond their what they currently know. Okay, so sorry, I'll skip through a couple slides because I went too long. But we tested it with many kids in the Bay Area, hundreds of kids, parents, and teachers. I'll skip this slide, but this was just kind of a very lofty slide. We launched on Kickstarter initially to the consumer market, and we have actually 4 days left in our campaign. We reached our funding goal in the first week, and now you can see where we're at. And we have kits ranging in price from $40 to $200, and all sorts of different projects are possible with the blocks that are all compatible. So kind of like Lego, if you bought an additional set to add on, they would all work with each other. So we're bringing electronics literacy to the world, and our mission is to democratize hands-on learning. And 2 slides at the end. So one thing we've learned is to build prototypes and often. As a hardware company, we found that we would sit in our rooms and just think a lot, but the act of building prototypes not only helped us kind of think through and figure out with our hands what was going on, but it also was a great way to show potential partners, investors. They were much more impressed if we showed them something tangible than just kind of saying we're going to build this awesome thing. So that'd be my one thing I learned. And what we need, support on Kickstarter, whether it's direct support in terms of you guys backing us, or just sharing our project with friends, family, colleagues, that'd be much appreciated. We're very interested in talking to potential partners that share our mission, angel investors, and advisors that have experience with business, fundraising, and kind of retail and merchandising. And lastly, we'd love to talk to educators here. In the fall, we're going to start pilot testing in schools, and we'd love to talk to anyone here who's affiliated with the school, tech camps, science museums, and see if we can work together. So thank you so much. That's our website. That's our Twitter handle. Yeah, sorry, I went over.
No, it's a problem. Okay, feedback from our judges.
Can you take a picture of the complicated circuit on the Elmo? Would it work?
Not at the moment. Okay. Oh, you mean with the app?
Yeah, would it show you the?
So it doesn't at the moment, but I kind of alluded to the ngSpice connection. Fundamentally, what we're going to do is take a physical built circuit, change it to a schematic, and then load it into a simulator, which would do kind of the heavy lifting. But it's not. That part's not working yet. Okay. Yeah.
So congrats on having all these different moving parts come together nicely and pre-selling, what, $100,000 of this on Kickstarter. That's great. I think more feedback than a question. One of the things we've seen being hardware investors is that you want people to be using this over and over and over again. So making sure that it's useful not just once, but many times. That's the difference between building a company that's like Lego versus building something that's like a science kit that you use once and then you forget about. So that's more just feedback.
Thank you, Rafa.
But congrats so far.
Thanks.
And just to follow up on that feedback, instead of just an LED light lighting up or a fan or something like that, if you could put it on a platform of a car that has wheels and it takes off. You know, make it, you know, from an engagement point of view, if you can give it a few platforms, like Ruminate has a room that you can change, right? And a car platform or a boat platform or something that makes it more engaging and more fun for a kid to come back and again and try different things. Because I think that's going to be your biggest challenge. I mean, you know, that's like Little Bits is a similar thing. I think they're going down the path of more thematic applications.
Yeah, I think that's a great point. And, you know, Lego, I think, has always been a great company, but they've really taken off, I think, because they've basically been showing people what they can build with Legos much more specifically. Like, you can build this fighter plane or you can build this boat. And I think kids like to have inspiration. Otherwise, they seem to move on easily to other stuff. What also I thought was really different was, you know, there's snap circuits have been around for a while and things like that, but I don't feel like, personally, they really teach concepts and showing them the actual kind of the software schematic of how the electrons are moving. That was a real difference in just putting together magnetic pieces versus really understanding what's happening. I thought that was really cool.
Thank you.
I wonder if you've thought about partnering with somebody with, you know, big IP, big intellectual property or characters. Because a lot of the Disneys of the world, the Marvels, want to get more into STEM and be more involved in this sort of movement that's going on. It's very trendy. Like, I could almost picture a Star Wars kid or something that, you know, sort of brought people in with the Star Wars, like build the Death Star, or, you know, not literally, but, you know.
So just adding on to that, so for Lego, at least 60% of their revenue is new business. It's new product lines. So licensing is actually a huge secret to their success. So that's exactly right.
Yeah, I mean, I just got back from Legoland. So.
Yeah, well, it's funny.
No, it's like Legoland is not Legoland. It's like, here's an Indiana Jones,
Star Wars,
Wars, everything with Legos, and just feels like it might be a great way to pull them in. I don't know what science character would actually fit, but you know,
it's neutral.
Transformers.
Yeah, that'd be awesome.
There you go. Okay, so now we're talking.
Yeah, we actually, I'm glad you mentioned that. We're talking to some people, including, I just realized, two of the people in the audience here, about kind of these sort of tie-ins. And it's not my area of expertise, but it's something that we think it could be awesome if, like, companies that, as you said, are interested in showing that they're, you know, they want to promote STEM and they want to kind of get their name out at the same time, and maybe some partnership. Yeah,
doing good by doing well, or doing well by doing good kind of thing.
I think that would take you out of the snap circuits, like all these kind of, like, because a lot of this is, to get big, you eventually want some physical retail. And, you know, those shelves are so noisy with packages that all look the same. And so if you can make them a little bit more emotional, I think, where the kid or the parent resonates with the character and the storyline, like there's a little bit more of a narrative to the product, those seem to be the bigger franchises that have longer lives.
Yeah. More comments from any comments from our audience?
Just, I would expand the augmented reality to boost her comment that, you know, from a parent's point of view, a parent's going to be the one that's saying, oh, this is great, let me purchase this for my children. And if you can kind of really ramp up the augmented reality and make it more like the lessons, like the guided lessons that you have later on, I think that would be so important for the parent, and they would just buy more kits if they felt like it had that beef.
Yeah, I think that's what we're most excited about, actually. Like, as you mentioned, you know, these existing companies have done this, and, you know, of course we try to make the hardware part as great as possible, but a lot of people will still say, how is this different from Snap Circuits? I think when we show them the AR part, not, you know, it's interesting because people say, they'll run up to us and say, oh, amazing potential to do this, and it's usually something that's on our list, but I'm glad that we didn't mention it. You know, they're the ones that see the possibility of, like, you know, guided lessons or interactive feedback, and these are things that, you know, we need to solve the technical challenge of making it recognizable, but given that, then we can kind of let other people help us with that, like educators, graphic designers. I mean, these are all made by me, and I'm not an artist, so you might have noticed it's just circles and so on, but that's the plan.
All right, let's hear it for LightUp. Oh, do we have a question from the audience?